Nice to have you once again. JAM 2001 past question. Question number 15. If a ray traveling in air is incident on a transparent medium, as shown in the diagram below, the refractive index of the medium is given as... Okay, let's have careful observation of the diagram. Look at the diagram. You can see light ray coming. That's the incident ray. You can see it bending. This refracted. Okay? Refracted ray. Incident ray. Okay? So the question is under refraction. Okay, from our option, if you have good knowledge of your Snell's law, you know that that option is centered on Snell's law, the second law of refraction, which says that given a pair of media, at the boundary of one pair of media, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. Okay, pay attention to the law. The law states, given a pair of media, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. Okay, let's break it down. Let's go back to the diagram. Okay, the diagram, you can see this is the boundary between two media. The first medium is air. The second medium wasn't specified. But there is a question you need to ask yourself. Between the two media, which one is denser? Which one is stronger than the other? The buzzword is density. Which one is denser? Okay, let's observe. Although the second medium wasn't stated, but you can decipher it yourself. Okay, let's see how. From the refraction, you will know. When light ray goes from one medium to another medium, it behaves in a way that will tell you the density of the second medium. Okay, if the ray on the process of bending shifts away from the normal, these are normal. This is normal. Any straight line on the surface that gives you 90 degrees from the surface or from the boundary, 90 degrees, that straight line is called normal. That's our normal. This is also normal. Okay, let's observe. If there was no refraction, if refraction has never occurred, this would have been the journey of this light ray. If it were only one medium, this would have occurred. But here we have two media, it will never happen. It's either the light ray is shifting away from the normal or bending towards the normal. You can observe the incident ray bends towards the normal. That's a clear indication that this other medium is denser. A denser medium, the ray will refract towards the normal. Less dense medium, the ray will refract away from the normal. Because this is a denser medium. So this is Snell's law. Okay, let's push ahead. And the law says, Snell's law says, N is equal to sine I. That is the angle of incidence, I. Please take notes. You measure all angles in optics from the normal. Don't be confused with this. This is what we call a distracting angle. Angle measured from the surface is just a distraction. It will help you to get the ray angle. The ray angle is the one measured from where? From the normal. Angle measured from the normal to the incidence ray is what we call the incidence angle or angle of incidence. So I'll call it I. That's what the law says, sine I over sine R is a constant. If you do this experiment 1 million times, provided you know the incidence angle and the refraction that will happen there, you pick the angle, sine it, sine that of refraction, find the ratio, keep using the same pair of media, you keep getting the same answer here. That's why we say it's a constant, and that constant is called refractive index. Keep on repeating the practicals. Provided you have the same pair of media, your incidence angle, sine it, over your refraction angle, sine it, you keep on getting the same N. It's a constant. You're using the same pair of media for goodness sake. So you keep getting the same thing. That's why we said earlier in that law, that the ratio of the sine of angle of incidence to the sine of the angle of refraction for a pair of media is a constant. Okay, let's go on. Then let's pick our angles. N is equal to sine. What I have here is I. So I'll maintain it I over. What I have here is beta. Sine beta. You can see this angle is properly measured. It's measured from the normal to the refracted ray. So this one is proper. Okay, it's I that is proper. But observing our options, there is no I in the option. They want me to feature this angle inside my equation. Then mathematics will help you. Mathematics will come to your aid. Are you aware that I and alpha, this symbol is called alpha. I plus alpha is equal to 90 degrees. Are you aware? This is 90 degrees, a quadrant. Alpha plus I is equal to 90 degrees. Observe. Alpha plus I is 90 degrees. You can see that. Okay, recall, we're trying to manipulate sine I to see if we get any of the arrangements in the option. Then sine I will also be the same thing as, if this is I, 90 minus alpha will also be my I. The angle here is also equivalent to 90 minus the angle here. So it will also be the same thing as sine, open brackets, 90 minus alpha, which is also the same thing as I. 90 minus alpha will also give me my what? I. Then in trigonometry, anytime angle 90 degrees is involved, there is a connection between sine and cos. Sine 90 minus alpha will also be the same thing as cos alpha. You can prove that from your calculator. Sine of 90 degrees minus alpha is the same thing as cos alpha. Okay, let's do a very simple, let's use a very simple example now. Let's take this alpha to be 60 degrees. 90 minus 60 is 30. Sine 30 will give you half. Remember, we'll call this one 60. 90 minus 60 will give 30. Therefore, sine 30 is half. Okay, go and do cos of that angle there, that alpha. Cos of 60 will also give you what? Half. Please take note of this. It's one of the trigonometric equivalents that every student must know. Trigonometric equivalents. That cos alpha is the same thing as sine 90 minus alpha. In the same way, sine alpha will be cos 90 minus alpha. Okay, let's go on. At this point, we are concerned with this. Then you can now see that I will change this to sine. First of all, let's change it to sine 90 minus alpha all over sine beta. Then finally, refractive index is equal to sine 90 minus alpha will be giving us cos alpha over, then finally, sine beta. Going back to our options. The correct option there is option A. Please take note of the trigonometric equivalence. Stay tuned as we push on. Thank you.